January 17, 1941. Coronado Hotel, San Diego, California. Charles Sorensen stared at papers scattered across the floor of his hotel room, each stack representing a different subassembly of the most complex aircraft ever designed for mass production. The vice president of production for Ford Motor Company had spent the entire night doing what aircraft industry experts said was impossible, sketching an assembly line that would produce one four-engine B-24 Liberator bomber every single hour. Outside his window, the Pacific Ocean stretched toward a war that was pulling America closer with every passing week. Inside, Sorensen's pencil scratched across Coronado Hotel notepaper, outlining a factory that would be 1 mile long and a quarter-mile wide. The aviation industry would mock this vision. "You can't expect a blacksmith to make a watch overnight," they'd say. But in 42 months, Ford would build 8,685 B-24 bombers at Willow Run, more than half of all Liberators produced, proving that American industrial democracy could outproduce anything the Axis powers could imagine. The sketch that Sorensen created that night, later initialed by Edsel Ford, Henry Ford II, and other Ford executives, would become one of the most important documents in American military history. Not because it was technically perfect, but because it represented a fundamental shift in thinking about what mass production could achieve. In January 1941, the United States military possessed 1,700 combat aircraft. No heavy bombers. This ranked America as the 18th strongest air force in the world, behind Romania. The humiliation of that statistic burned through military leadership. President Franklin Roosevelt had shocked the nation during his May 26, 1940, fireside chat, demanding 50,000 combat aircraft within 12 months. His goal exceeded every airplane built in America since the Wright brothers' first flight at Kitty Hawk in 1903. The aviation industry couldn't meet this demand. Traditional aircraft manufacturing relied on skilled craftsmen working on individual planes. Each bomber was essentially custom-built. Workers memorized specifications rather than following standardized drawings. Experienced foremen held crucial knowledge that existed nowhere else. Quality depended on individual skill rather than systematic processes. Consolidated Aircraft in San Diego built B-24 Liberators by hand, outdoors, on steel fixtures that warped in the California sun. Engineers used surveyors' transits mounted on pickup trucks to align propeller shafts. The temperature differential between California's hot days and cool nights caused metal fixtures to expand and contract by measurable amounts. This meant morning assemblies didn't match afternoon tolerances. Workers compensated by hand-filing parts to fit. It took them 4 hours just to hang a single engine, 16 hours to install all 4 engines on one aircraft. They produced 1 bomber per month, maybe 2 if everything went perfectly. At this rate, America would lose the war before it officially began. The B-24 Liberator represented everything aviation engineers believed couldn't be mass-produced. 67 feet long with a 110-foot wingspan. 4 Pratt & Whitney R1830 engines, generating 1,200 horsepower each. 30,000 separate components, 450,000 parts, 360,000 rivets in 550 different sizes, 18 tons of aluminum, steel, and rubber. The bomber dwarfed anything Ford had ever manufactured. A Ford V8 automobile contained 15,000 parts and weighed 3,000 pounds. The B-24 was 30 times more complex and 6 times heavier. "You're comparing a garage to a skyscraper," industry veterans warned Sorensen. Aviation manufacturers saw fundamental differences between cars and aircraft. Cars operated on the ground at low speeds with minimal consequences for minor defects. Aircraft flew at 25,000 feet at 290 miles per hour where a single failed rivet could cause catastrophic structural failure. Cars could be recalled and repaired. Aircraft failures killed 10-man crews. The stakes demanded craftsmanship, not assembly lines. Or so the experts believed, but Sorensen saw something they didn't. He saw the fundamental principles of mass production: break complex products into standardized units, build them in parallel, then bring them together on a moving assembly line. The same principles that let Ford produce 10,000 cars per day at River Rouge. The same principles that had revolutionized American manufacturing. The same principles that, if applied to aircraft, could change the course of the war. Sorensen had spent decades refining these principles. In 1913, he'd helped develop the first moving assembly line at Ford's Highland Park plant. That innovation reduced Model T assembly time from 12 hours to 93 minutes. At River Rouge, 100,000 workers turned raw materials into finished automobiles. Iron ore and coal entered one end. Complete cars drove out the other. Sorensen understood that complexity was just scale. Scale was just organization. Organization was just disciplined thinking. The stakes couldn't be higher. Germany's Luftwaffe dominated European skies. Over 4,000 combat aircraft supported the Wehrmacht's blitzkrieg across Europe. Britain stood alone, bleeding under nightly bombing raids. The Blitz had killed 43,000 British civilians. German industry produced aircraft at an accelerating rate. If America couldn't deliver heavy bombers in massive numbers, the Allies would fall. And if the Allies fell, democracy would fall with them. Sorensen knew the experts would ridicule him. He knew aircraft manufacturers would resist. He knew even his own company's engineers would doubt. Aviation industry representatives already dismissed automobile manufacturers as incapable of understanding aircraft complexity. But on that January night in San Diego, Charles Sorensen made a decision that would reshape modern warfare. He would build a factory unlike anything the world had ever seen. He would prove that American mass production could manufacture anything, even flying fortresses. He would show Adolf Hitler that when America's industrial machine shifted into high gear, no enemy could match it. The mathematical advantage would be overwhelming. Germany might build better individual aircraft, but America would build 10 aircraft for every one German plane. Quality through quantity. Victory through industrial might. The visit that changed everything. Charles Sorensen arrived at Consolidated Aircraft's San Diego plant on January 16, 1941, expecting precision. Instead, he found chaos that violated every principle of mass production. Workers assembled B-24s outdoors under the open California sky. Steel fixtures, exposed to temperature swings from day to night, expanded and contracted constantly. Sorensen watched an engineer measure a wing mounting point in the morning, then remeasure the same point in the afternoon. The difference, 3/8 of an inch. In aviation, where tolerances were measured in thousandths of an inch, this was catastrophic. Surveyors used transit equipment mounted on pickup truck pallets to align propeller shafts, a method accurate to mere inches, not the thousandths required. No two aircraft were identical. Wing sections built in one area didn't fit fuselages built in another. Engineers made constant adjustments, filing parts by hand, forcing components together. Sorensen watched workers hammer aluminum panels into place. Hammering. On precision aircraft, quality control was reactive, not preventive. Inspectors examined completed assemblies and rejected those that didn't meet specifications. But rejection came after hours of wasted labor, after expensive materials had been consumed, after the assembly had moved through multiple stations. Reuben Fleet, Consolidated's president, defended the operation proudly. "We've always built aircraft this way," he explained. This is craftsmanship. Our workers are the best in the industry. Each aircraft receives individual attention. Fleet showed Sorensen their most experienced workers, men who'd been building aircraft for 15 or 20 years. These master craftsmen could look at an assembly and know instinctively if it was correct. They could hear an engine and diagnose problems by sound alone. They could feel a rivet and know if it was properly installed. Fleet considered this expertise irreplaceable. Sorensen considered it a bottleneck. He watched a team spend an entire afternoon installing one engine. 4 hours for a single engine. The team consisted of 3 highly skilled mechanics. They positioned the engine with a hoist, then spent hours adjusting mounting points, testing electrical connections, routing fuel lines, connecting hydraulic systems. Each step required consultation, measurement, adjustment. 16 hours to install all 4 engines. At this pace, one complete bomber required 3 to 4 weeks of final assembly, not counting the weeks or months required to build sub-assemblies. This should have been impossible, Sorensen thought, except it wasn't just possible. It was normal for the aircraft industry. Consolidated wasn't incompetent. They were following industry best practices. Every aircraft manufacturer in America operated similarly. Boeing built B-17s the same way. Douglas built aircraft the same way. North American built aircraft the same way. Handcrafted, individual, slow. That night, back at the Coronado Hotel, Sorensen couldn't sleep. The images of outdoor assembly, warped fixtures, and handcrafted adjustments haunted him. America needed bombers desperately, but the aviation industry couldn't scale. Their methods couldn't produce aircraft fast enough. The mathematics were brutal. If Consolidated took 1 month to build one bomber, they could produce 12 bombers per year. Germany was producing hundreds. Sorensen began sketching. Not complicated blueprints, just simple pencil drawings on hotel notepaper. He started with the fundamentals. Every complex product could be broken into components. Every component could be standardized. Every standardized component could be mass-produced. He listed every major unit of the B-24: fuselage, wings, tail assembly, landing gear, engines, turrets. Then he broke each major unit into subunits: fuselage, nose section, cockpit section, bomb bay section, aft fuselage, tail cone, wings, center wing section, outer wing panels, ailerons, flaps, wingtips, tail assembly, vertical stabilizer, rudder, horizontal stabilizers, elevators. Then subunits into individual components: center wing, main spar, ribs, stringers, skin panels, fuel cells, engine mounts, each component into its constituent parts. Soon papers covered his hotel room floor in organized stacks. Each stack represented one assembly station. Sorensen walked around his room, studying the stacks. He visualized the flow. Raw aluminum entered at one end. Stamping presses created skin panels. Extrusion machines formed stringers and ribs. Workers assembled components into sub-assemblies. Sub-assemblies moved to the main line. The bomber took shape station by station. He calculated timing for each operation. If a fuselage required 200 hours of labor and 20 workers operated on it simultaneously, the fuselage could be completed in 10 hours. If wings required 300 hours of labor distributed across 30 workers, wings could be completed in 10 hours. If tail sections required 100 hours of labor distributed across 10 workers, completion in 10 hours. All components completing simultaneously, converging on the main assembly line at precisely timed intervals. He estimated required floor space. A B-24 was 67 feet long with a 110-foot wingspan. Each aircraft in final assembly needed approximately 12,000 square feet. If 50 aircraft were in final assembly simultaneously, He needed 600,000 square feet just for final assembly. Add sub-assembly areas, parts manufacturing, receiving, shipping, support facilities. 3 million square feet minimum. Maybe 4 million to ensure adequate space. By 4 o'clock in the morning, Sorensen had it. A factory 1 mile long and a quarter-mile wide. The largest single building ever constructed. An L-shaped layout to accommodate property boundaries and the planned airport. Dual parallel assembly lines for redundancy. Specialized production zones feeding into the main lines. An assembly line that would move B-24s through standardized stations, adding components at precisely timed intervals. 1 bomber every hour. The mathematics were elegant. If each station completed its work in 1 hour and aircraft moved through 24 stations, 24 aircraft would be in production simultaneously. Every hour, 1 aircraft completed and another began. Continuous flow, continuous production. The sketch, which Sorensen would later have Edsel Ford, Henry Ford II, and other executives initial, outlined the true Willow Run. Not the facility that would struggle through 1942 and early 1943, but the industrial colossus that would eventually emerge. A vision of what American mass production could achieve. The prisoners. The first transport carried 1,000 prisoners from Buchenwald concentration camp. They arrived expecting temporary work assignments. They discovered they were entering a tomb. The existing Kohnstein tunnels were designated Tunnel A and Tunnel B, 2 parallel tubes running north to south through the mountain, connected by 46 cross galleries, numbered 1 through 46. Each main tunnel was approximately 1.8 kilometers long. The cross galleries varied in length, the longest extended nearly 200 meters. Total existing tunnel length, approximately 15 kilometers. Kammler's plan required expanding this to over 30 kilometers. The prisoners would do the excavation. By hand, with minimal equipment, on starvation rations. In conditions that violated every principle of human survival. The first priority was creating space for rocket assembly. Even before excavation was complete, prisoners began preparing the tunnels for production machinery. They laid narrow-gauge railway tracks throughout the tunnel system. They installed electrical systems for lighting and power. They constructed wooden platforms and workstations, all while living inside the tunnels themselves. There were no barracks, no beds, no sanitation facilities. Prisoners slept on the rock floor of the tunnels or in excavated side chambers called Schlafstollen. Sleeping tunnels. 4-tier wooden bunks were eventually constructed, but these remained damp, infested, and provided no privacy or comfort. The tunnels were cold. Temperatures hovered around 50 degrees Fahrenheit. Prisoners received no blankets initially. They wore thin striped uniforms that provided no warmth. Dampness was constant. Water seeped through cracks in the rock. The air was thick with dust from excavation, exhaust from diesel locomotives, and fumes from primitive chemical toilets that quickly overflowed. Lighting was minimal. Bare bulbs created pools of light with vast dark spaces between. The noise was crushing and constant. Jackhammers breaking rock. Diesel locomotives hauling ore cars, generators powering machinery. Shouted orders from guards, screams from beaten prisoners. Prisoners worked in 12-hour shifts initially. This escalated to 18-hour shifts, sometimes 72-hour marathons with no rest. The work was murderous, breaking rock with jackhammers and pickaxes. Loading broken stone into ore cars, pushing the heavy cars along tracks, constructing concrete foundations for machinery, installing electrical systems and water lines. Every task was done by hand. Every task was done under the threat of immediate violence. SS guards and civilian overseers carried clubs, whips, and guns. Any prisoner who moved too slowly was beaten. Any prisoner who rested was beaten. Any prisoner who fell from exhaustion was kicked until he stood, or died. The guards had a saying, "You have to go through the chimney," meaning prisoners were expected to die. Food consisted of watery soup once or twice per day, a piece of bread that often contained sawdust filler. No vegetables, no protein. Approximately 1,000 calories daily, less than half what a man performing hard labor requires. Prisoners lost weight catastrophically. Within weeks, healthy men became skeletal. Within months, many were too weak to work. Those too weak to work were sent back to Buchenwald or to Auschwitz to be killed. Or they simply died in the tunnels. Medical care was virtually non-existent. A camp doctor provided minimal treatment. Aspirin for pain, nothing for serious illness or injury. Diseases spread rapidly in the confined, unsanitary conditions. Dysentery was endemic. Tuberculosis infected thousands. Pneumonia killed in the cold, damp environment. The mortality rate during the first 7 months, August 1943 to March 1944, was the highest of any concentration camp in the Nazi system. Approximately 6,000 prisoners died during tunnel expansion and factory construction. That's 1 death for every 10 meters of tunnel excavated, 1 death for every day of operation. Bodies were carried out on the same ore cars that carried broken rock. They were stacked like lumber near the tunnel entrances. Eventually transported back to Buchenwald for cremation. The SS kept meticulous records of deaths, not out of concern for the dead, but to maintain labor inventory. Each death meant requisitioning a replacement prisoner. The system was coldly efficient. Prisoners arrived, worked until they died, were replaced by new prisoners. The underground factory consumed human lives like fuel. The factory takes shape. By December 1943, the tunnel system had been expanded sufficiently to begin rocket production. The Mittelwerk factory officially began operations. The organizational structure was corporate, not military, at least on paper. Mittelwerk GmbH was a limited liability company created specifically for V2 production. Georg Ricke served as general manager. Albin Sawatzki was technical director. Arthur Rudolph led the technical division responsible for rocket assembly. These men were civilians working under government contract. But they oversaw a workforce of concentration camp prisoners guarded by the SS. The moral implications were clear to everyone involved. The production process was divided between the 2 main tunnels. Tunnel A housed rocket component manufacturing and subassembly. Tunnel B contained the final assembly lines. The 46 cross galleries served as specialized workshops. Gallery 1, fuel tank production. Gallery 10, turbopump assembly. Gallery 20, warhead section manufacturing. Gallery 28, gyroscope and guidance system installation. Gallery 41, final assembly and testing. Each gallery was a specialized factory within the factory. Components moved through the system on narrow-gauge railways. The logistics were extraordinarily complex. A V2 rocket contained approximately 20,000 individual parts. Each part was manufactured in a specific gallery. Sub-assemblies were created in other galleries. Everything had to arrive at final assembly in perfect sequence. Any delay at any stage stopped the entire production line. The rocket itself was a marvel of engineering and a nightmare to manufacture. Length 14 meters, 46 feet. Diameter 1.65 meters, 5.4 feet. Weight at launch 12,500 kilograms, 27,500 pounds. Fuel, liquid oxygen and 75% ethanol water mixture. Engine, single-chamber rocket motor producing 25 tons of thrust. Warhead, 1,000 kilograms, 2,200 pounds of amatol explosive. Range, 320 kilometers, 200 miles. Speed, Mach 4, 3,500 miles per hour. The precision required was extreme. Fuel tanks had to be leak-proof. Liquid oxygen boils at 183 degrees Celsius and would freeze or destroy any imperfect seal. The turbopump had to deliver 125 kilograms of fuel per second without failure. The guidance system had to maintain trajectory accuracy within meters over 200-mile distances. Any defect anywhere meant the rocket would explode on the launch pad in mid-air or miss its target entirely. Quality control was supposedly rigorous. In practice, it was inconsistent. The factory used a mix of skilled German workers and unskilled forced labor. German workers numbered approximately 2,500 at peak production. They operated machinery, oversaw assembly, and conducted quality inspections. Concentration camp prisoners numbered approximately 5,000 in production roles at peak. They performed the repetitive, dangerous tasks. The skill mismatch created constant problems. Prisoners had no training in rocketry or precision manufacturing. Many had no industrial experience at all. They were academics, merchants, farmers, or professionals arrested for political or racial reasons. Teaching them complex technical tasks while beating them for working too slowly was contradictory and counterproductive. The result was a high defect rate. Perhaps 30 and 40% of V-2 rockets experienced failures, launch pad explosions, mid-air disintegrations, guidance system malfunctions causing rockets to fly wildly off course. Many rockets landed harmlessly in the North Sea or English countryside, but enough work to kill 2,750 people in London and another 1,600 in Antwerp, Belgium. The mathematics were brutal and damning. Approximately 6,000 V-2 rockets were produced at Mittelwerk between September 1944 and March 1945. They killed approximately 5,000 people total, but producing them killed at least 20,000 concentration camp prisoners. The V-2 program was the only weapons program in history where manufacturing was more lethal than deployment. The jet engines. While V-2 production dominated Mittelwerk, jet engine manufacturing occurred in a separate section. In early 1944, Albert Speer's emergency fighter program demanded massive increases in jet fighter production. The Messerschmitt Me-262 was Germany's best hope for countering Allied air supremacy. The Me-262 required two Junkers Jumo 004 turbojet engines. The Jumo 004 was the world's first mass-produced jet engine. Specifications: 8-stage axial flow compressor, 6 individual combustion chambers arranged in a ring, single-stage turbine, thrust 1,980 pounds, 900 kilograms, weight 1,850 pounds, 840 kilograms. The engine was revolutionary but problematic. Time between overhauls, 10 to 50 hours, depending on pilot skill and luck. The engines required high-temperature alloys, specifically nickel and chromium. By 1944, Germany's access to these metals was severely limited. The Jumo 004B production variant used substitutes. Turbine blades were made from tinidor or chromodor, stainless steel alloys that used less nickel. Combustion chambers were mild steel. They had to be replaced every 25 hours. The result was an engine that worked but was fundamentally unreliable. Producing these engines required precision manufacturing impossible in the chaotic underground environment. Yet Speer ordered that Mittelwerk dedicate tunnel space to jet engine production. The Nordwerk, North Works, was established in the northern half of the tunnel system. Approximately 2,400 Jumo 004 engines were manufactured at Mittelwerk in 1944-1945. Production rates never approached targets. The same problems that plagued rocket production affected jet engines: unskilled forced labor, material shortages, quality control failures. Additionally, jet engine production required machine tools and precision equipment that was difficult to obtain and maintain underground. Compressor blades had to be machined to tolerances measured in thousandths of an inch. Turbine wheels had to be perfectly balanced. Combustion chambers required specialized welding techniques. The prisoners doing this work had no training. The German supervisors had minimal jet engine experience. Jet technology was brand new. The working conditions made precision impossible. Cold temperatures affected metal properties and machine tool accuracy. Dampness corroded precision equipment. Dust contaminated assembly areas. Poor lighting made inspection difficult. Many engines left Mittelwerk with defects that wouldn't be discovered until they failed in flight, often catastrophically. German pilots learned to treat their jet engines with extreme caution. Throttle movements had to be slow and gentle. Sudden acceleration caused compressor stalls. Acceleration from idle to full power required 15 seconds, an eternity in combat. The engines would flame out without warning. Both engines failing simultaneously meant certain death. Despite these problems, the Me-262 was a formidable weapon when it worked. Top speed, 540 miles per hour, 100 mph faster than any Allied fighter. Armament, 430mm Mk108 cannons with devastating firepower. Range, 650 miles. In combat, Me-262s destroyed between 300 and 450 Allied aircraft, but fewer than 300 Balded Me-262s ever operated simultaneously. Production couldn't keep pace with losses. Pilot training couldn't keep pace with casualties. Fuel shortages grounded many operational aircraft. And the engines, those unreliable Jumo 004s manufactured at Mittelwerk, failed constantly. Other underground factories. Mittelwerk was the largest underground weapons factory, but not the only one. Across Germany and occupied territories, the Nazi regime built dozens of underground facilities. Weingut Warm, Vineyard Y in Bavaria, was designed to manufacture Me-262 jet engines on an even larger scale than Mittelwerk. Construction began in May 1944 in the Mühldorfer Hart Forest. The design used an innovative construction method. Workers piled massive mounds of gravel. 2-meter-thick reinforced concrete arches were poured over the gravel. Once the concrete hardened, the gravel was excavated from underneath. This created huge vaulted spaces 32 meters high, tall enough for multi-story factories. The scale was staggering. 12 massive arch sections were planned. Each arch was 85 meters wide and 32 meters high. Total floor space would exceed 75,000 square meters. The facility would manufacture complete jet engines with a 9-story factory inside each arch. Labor came from Dachau concentration camp. Workers lived in small wooden huts scattered through the surrounding forest. Triangular structures covered with earth for camouflage. No heating, no sanitation, minimal shelter. Prisoners worked 10-12-hour days moving gravel, working with concrete, installing rebar. The work was as deadly as at Mittelwerk. Thousands died during construction. But Weingut I was never completed. The war ended before production could begin. All the suffering, all the deaths, all the massive construction effort produced nothing but corpses. The Wolpersberg facility near Kala was another underground Me-262 factory. Construction began in late 1944. Existing sand mine tunnels were expanded to 30 kilometers. An inclined railway was built to move completed aircraft from the tunnels up to a runway on top of the mountain. The workforce, 12,000 forced laborers from Italy and Eastern Europe, plus 3,000 skilled workers. The first Me-262 took off from Wolpersberg on February 21, 1945. Only 20 to 30 completed aircraft left the facility before American troops liberated it on April 12–13, 1945. Similar facilities were constructed throughout Germany and Austria. Ebensee in Austria, subcamp of Mauthausen concentration camp. Gusen in Austria, more Mauthausen subcamps, building underground factories. Kaufering in Bavaria, 11 subcamps building underground aircraft facilities. None were completed before war's end. All consumed thousands of lives. The pattern was consistent: ambitious plans, massive construction efforts, horrific death rates, and minimal or zero production. SS General Hans Kammler, the same man who built Mittelwerk, oversaw many of these projects. He applied the same philosophy everywhere. Prisoner lives were expendable, production deadlines were absolute. The results were predictable. Thousands died building facilities that never produced weapons. The underground factory program became a monument to Nazi Germany's final desperation, pouring resources into unrealistic projects while the military situation collapsed, killing tens of thousands to build facilities that couldn't possibly be completed in time, sacrificing human lives for weapons that couldn't change the war's outcome. Liberation and aftermath. By early April 1945, the military situation was hopeless for Germany. Soviet forces were approaching Berlin from the east. American and British forces were advancing across Germany from the west. The Nordhausen area, location of Mittelwerk, lay in the path of the American advance. On April 4, 1945, the SS began evacuating Mittelbau Dora concentration camp. Prisoners were forced onto death marches. Thousands died during these marches, shot if they couldn't keep pace, or succumbing to exhaustion and starvation. Some prisoners were packed into trains, boxcars filled beyond capacity. Many died in transit. The evacuation was chaos. Some prisoners were sent to Bergen-Belsen in northern Germany. Others were marched toward camps in Bavaria. The SS wanted to hide evidence of their crimes and prevent prisoners from being liberated to testify. On April 3 and 4, 1945, the Royal Air Force bombed Nordhausen. The target was supposedly the Mittelwerk factory. But the bombs hit Nordhausen city and killed approximately 1,300 to 1,500 prisoners housed in the Bölker Kaserne, a former Luftwaffe barracks that had become a Sterbelager, a camp for the dying. The prisoners were too sick or weak to work. The SS had concentrated them in Nordhausen, awaiting evacuation or death. The RAF bombs completed what the SS had started. Survivors described the horror. Buildings collapsed on helpless, emaciated prisoners. Fire consumed structures filled with people too weak to escape. The Allies didn't know prisoners were concentrated there. Reconnaissance had identified it as a military barracks. On April 11, 1945, units of the U.S. 3rd Armored Division entered Nordhausen. They expected to find a German military installation. Instead, they discovered hell. Lieutenant Colonel George Textor, one of the first Americans into the camp, later wrote, "The odor of death was overwhelming. Hundreds of corpses lay where they'd fallen. Some had been dead for days. Others had died hours before liberation. Approximately 3,000 sick and dying prisoners remained. Many were too weak to move. Some couldn't comprehend that liberation had come. American soldiers, hardened by months of combat, wept at the sight. Medics worked frantically to save those who could be saved. Many died despite medical care. They were simply too far gone. American commanders ordered German civilians from Nordhausen to tour the camp, to see what had been done in their name. Many claimed they didn't know. The camp was only a kilometer from the tunnel entrances. Thousands of prisoners had marched through Nordhausen daily. The cremation facilities at nearby Buchenwald had been working constantly. The claim of ignorance was implausible. On April 11th, American engineers entered the Mittelwerk tunnels. They found an industrial facility unlike anything they'd seen. Miles of underground galleries, railway tracks throughout, sophisticated machinery, partially assembled V-2 rockets standing vertically in assembly fixtures, jet engine components, technical drawings and documentation. The Americans also found evidence of the human cost: bloodstains on floors, makeshift gallows where prisoners had been hanged, the sleeping areas where thousands had lived in inhuman conditions. The American military quickly recognized Mittelwerk's value. Operation Paperclip was already underway, a program to capture German scientists and technology. V-2 rockets represented technology years ahead of American rocketry. Jet engines represented the future of aviation. The decision was made immediately: seize everything before the Soviets arrived. The Nordhausen area had been designated as part of the Soviet occupation zone under Allied agreements. The Americans had only weeks before Soviet forces would take control. Special Mission V-2 was organized. American troops worked around the clock. They dismantled rockets. They crated components. They boxed documentation. They loaded everything onto trains. On May 22, 1945, the first trainload of V-2 parts left Nordhausen for Antwerp, then by ship to America. In total, the Americans captured enough components for approximately 100 complete V-2 rockets. They also captured the scientists. Wernher von Braun and his team of rocket engineers had already surrendered to American forces. Arthur Rudolph, production manager at Mittelwerk, was brought to America under Operation Paperclip. Georg Ricke, Mittelwerk's general manager, was initially held for war crimes trials, but was ultimately acquitted. The Soviets arrived on May 26, 1945. They found an empty factory. The Americans had taken everything of value. The Soviets captured what remained: machine tools, some jet engine components, lower-level engineers and workers. They also found thousands of corpses and a few surviving prisoners. The full horror of Mittelbau Dora took years to fully document. Final estimates: approximately 60,000 prisoners passed through the Mittelbau Dora camp system. Approximately 20,000 died, 1 in 3. Causes of death: exhaustion and overwork, thousands; starvation, thousands; disease, thousands; beatings and executions, at least 350 hanged, countless others beaten to death. Air raids: 1,300–500 killed in April 1945 RAF bombing. Death marches: thousands more in the final weeks. The survivors carried physical and psychological scars for life. Malnutrition caused permanent health problems, lung diseases from tunnel dust and poor air. Psychological trauma that never healed. Nightmares of the tunnels that lasted decades. The trials and the questions: after the war, justice was pursued, incompletely. The Dora trial was held in 1947 at Dachau. 15 SS guards and capos were convicted. 1 was executed. 4 defendants were acquitted. The trial addressed the question of liability for engineers and scientists. Georg Ricke, Mittelwerk's general manager, was acquitted despite clear evidence of his knowledge and involvement. Arthur Rudolph was never charged. He immigrated to America in 1945 under Operation Paperclip. He became a key figure in the U.S. space program. He directed development of the Pershing missile. He served as project director for the Saturn V rocket that sent Americans to the moon. In 1984, the U.S. Justice Department began denaturalization proceedings against Rudolph. Evidence showed he'd been aware of conditions at Mittelwerk. He'd attended meetings discussing the need for more slave labor. He'd toured the facilities and witnessed the conditions. Rather than fight the proceedings, Rudolph renounced his U.S. citizenship and returned to Germany. West Germany declined to prosecute, citing statutes of limitations. He died in 1996, having received honors for his rocketry work, but facing condemnation for his Mittelwerk role. Wernher von Braun faced similar questions. He'd visited Mittelwerk multiple times. He'd attended meetings with Himmler and other SS leaders. He'd known conditions in the tunnels, yet he was never charged with war crimes. He became a naturalized U.S. citizen in 1955. He directed development of U.S. rocket and space programs. He became a celebrity, appearing on television, writing books, advising Disney films about space exploration. He died in 1977, lauded as a hero of space exploration. The moral questions remain unresolved. Can scientists claim ignorance when their work uses slave labor? Can engineers say they were just following orders when their designs killed thousands in production? Can we celebrate technological achievement built on human suffering? The V-2 rocket technology, captured at Mittelwerk, formed the foundation of the US and Soviet space programs. Every launch, Mercury, Gemini, Apollo, Soyuz, Space Shuttle, traced its lineage to those tunnels. Every satellite in orbit owes something to the work done under the Konstein. But that work was done by prisoners beaten, starved, and worked to death. The jet engine technology influenced post-war aviation development. The Jumo 004 was copied by the Soviets as the RD-10. It powered early Soviet jets. Allied engineers studied captured Jumo engines intensively. Lessons learned influenced British and American jet engine design. The underground factory concept influenced Cold War military planning. Both superpowers built underground command centers, missile silos, and strategic facilities. The idea that critical infrastructure could be protected deep underground became standard military doctrine, all tracing back to the Nazi underground factory program, all built initially on slave labor and mass death. The legacy today, the Mittelbau Dora Memorial Site, preserves part of the tunnel system. Visitors can walk through a section of Tunnel A. The narrow-gauge railway tracks remain. Some V-2 components still litter the floor: propellant tanks, nose cones, gyroscopes. A V-2 engine assembly is displayed in the tunnel. It's cold, damp, and claustrophobic. Even with modern lighting and visitors walking freely, the oppressive atmosphere remains. Imagining the conditions prisoners endured is difficult but necessary. The memorial includes the former concentration camp site. Foundations of barracks remain visible. Memorials honor the dead from various nations: Soviet prisoners, French resistance fighters, Polish political prisoners, Italian workers, German anti-fascists. The roll call area where 200 men were publicly hanged for suspected sabotage is marked. The crematorium where bodies were burned is preserved. Educational exhibits document the camp's history: personal testimonies from survivors, photographs from liberation, technical documentation of the weapons produced. The moral questions the site raises. The facility was designated a National Historic Site in 1991. It's protected from further damage, though surface gypsum mining continues elsewhere in the region, threatening the stability of remaining tunnels. Plans exist to expand the memorial and build a new documentation center. The goal: ensure future generations understand what happened, ensure the dead are remembered, ensure the lessons are learned. Because Mittelbau Dora represents something terrifying about technological advancement and war: the capacity to justify any atrocity in pursuit of military victory, the ability to reduce human beings to disposable tools, the willingness to sacrifice thousands for weapons that ultimately changed nothing. Germany lost the war despite the V-2. Germany lost the war despite the Me-262. The wonder weapons were wonders of engineering, but failures of strategy. The underground factories were marvels of construction, but monuments to cruelty. 20,000 died building weapons that killed 5,000. 20,000 died building factories that mostly never produced anything. 20,000 died because Nazi leadership believed technology could substitute for sound strategy and adequate resources. The mathematics of desperation are always cruel. The mathematics of Mittelbau Dora were especially so. Epilogue. The hidden factory under the Kohnstein mountain was supposed to be impregnable. No Allied bomb could penetrate hundreds of feet of solid rock. No reconnaissance aircraft could photograph what lay deep underground. No saboteur could access the heavily guarded facility. In theory, Mittelwerk represented perfect security. In practice, it represented perfect failure. The security that protected the factory from bombs couldn't protect it from its own contradictions. You cannot build precision weapons using slave labor. You cannot maintain quality control while beating workers to death. You cannot sustain production when your workforce is dying at rates exceeding replacement. The underground factory consumed resources Germany couldn't spare. Concrete and steel for tunnel construction. Machine tools diverted from other production. Transportation capacity for moving materials and prisoners. Food to keep prisoners alive. Though barely. SS personnel to guard the operation. Engineers and scientists who could have been used elsewhere. All for weapons that arrived too late and in too small quantities to matter. The first V-2 launched from Mittelwerk hit London on September 8, 1944. By then, the Allied armies had liberated Paris and were advancing toward Germany's borders. The Me-262s, powered by Mittelwerk jet engines, entered combat in late 1944. By then, Germany had already lost control of its airspace, and fuel shortages grounded most aircraft, regardless of performance. The wonder weapons were wonders, but they were irrelevant to the war's outcome. Germany had already lost by the time they arrived. The strategic situation was too far gone. The resource imbalance was too extreme. No weapon, however advanced, could compensate for fighting the Soviet Union, the United States, and the British Empire simultaneously. But Hitler believed in miracles. He believed in wonder weapons that would reverse impossible situations. He believed that will and technology could triumph over mathematics and logistics. So he ordered the underground factories built. He ordered the prisoners worked to death. He ordered production at any cost. And 20,000 people paid that cost. Their names are mostly forgotten. The individual stories are mostly lost. But the evidence of their suffering remains. In the tunnels under the Kohnstein, in the concentration camp site at Mittelbau Dora, in the memorial stones and documentation, in the survivors' testimonies recorded before they died. The hidden factory was supposed to win the war. Instead, it became a monument to the human cost of fanaticism. A reminder that technological advancement is not inherently progressive. A warning that the pursuit of wonder weapons can lead to horrific atrocities. The tunnels remain, silent now, empty of machinery, empty of prisoners, but full of memory, full of the ghosts of 20,000, who died in darkness, who never saw the sun, who built weapons for masters who considered them less than human. The hidden factory under the mountain, built to win a war, became instead a tomb for thousands, whose only crime was being in the path of totalitarian ambition.